All of you complete at point A. Anybody is having doubt, you can ask me. Clear, guys? So, what is the maximum energy possessed by the body? Potential energy? All of you. At point A. At point A, what is the energy possessed? 800 joules. Okay. Now, at point B. So, if you notice it at point B, body is above from the ground. How much height, guys? Body is above from the ground. At
3
point B.
meters.
Everybody? 3 meters. Next at point C, 2 meters. At point D, 1 meter. Just above from the ground. So their potential energy is zero and kinetic energy is maximum. So let me take second case 2. Now, body is at where? Mitakshri? At point B. Understanding? So at point B, what is the height above from the ground? All of you. Yes, please. Height above from the ground. What is that?
3 meters.
3 meters. Okay. Now, potential energy is equals to, what is the formula? mgh, which is equals to 20 into 10 into 3, which is equals to 600 joules. So, as we all know, at any point, the potential energy lost by the body is equals to what energy? Everybody? Yes, please. Answer to my question. Potential energy lost by the body, which is equals to what? Mr. Noor?
Kinetic energy
Kinetic energy.
By the body. So, which is equals to, as we all know, what is the potential energy, total potential energy? Everybody? At the point A, 800. So, 800 minus 600, which is equals to how much? Kinetic energy now. Kinetic energy is equals to 200 joules. That is what you have to remember. So here what is that? Potential energy lost by the body is equals to kinetic energy gained by the body. Yes or no, Abhirami? Gained by the body. Mr. Aswin, understand Aswin? Omar, Gokul, anything doubt you can ask me. Noor? Okay, that is what you have to remember. Next. Next. So if you have done total energy. So what is the total energy? Everybody? Total energy. You can notice it. How much? EP plus EK. Potential plus kinetic energy equals to 600 joules plus 200 joules. Which is equals to how much? 800 joules. Understand? All of you? Aswardhan? Okay, that is what. Next, third case. Case 3. This is case 2. Case 2 it is, and that is case 3. Now, case 3. So, tell me at point where? At point, all of you. At point C. So, at point C, what is the height of the object above from the ground? Everybody? Height of the object above from the ground. Everybody? 2 meters. Understanding? So, at H is equals to 2 meters. So, now potential energy is equals to M into G into H, which is equals to 20 into 10 into 2, which is equals to 400 joules. Clear? Very good, Noor. So now, as we know, kinetic energy is equals to the potential energy lost by the body. So kinetic energy is equals to 800 minus 400, which is equals to 400 joules. You all need to solve. If you are not solving, you cannot. You must solve, everybody. Mr. Kaushik, never open your mouth. I don't know what. Mr. Sanjay solving, Sanjay, Gokul. That is what it is. So now total energy again. Total energy is equals to, observe, how much? 400 joules plus 400 joules, which is equals to what, guys? Again, 800 joules. So at point C also, total energy remains constant. Next, at point D, we have taken. So at point D, so height above from the ground, height above from the ground is 1 meter. So if you have taken potential energy is equals to mgh, which is equals to 20 into 10 into 1, which is equals to how many joules, guys? All of you. Metakshri, 200 joules. Yes or no? So we all know the energy, potential energy lost by the body is equals to kinetic energy gained by the body. So 800 minus 200 joules, which is equals to how much kinetic energy? 600 joules. That is what you have to remember. So total energy is equals to potential energy plus kinetic energy. If you have done, so what will happen? 200 plus 600, which is equals to 800 joules. Clear? I want response. Mr. Sanjay, Omar, understand Omar? Solving Abhirami, Sanjay. That is what you have to remember. Now, just above from the ground, just above from the ground. So above from the ground means all of you knows height is equals to what, guys? Mitakshri, h is equals to what? 0 meters. So potential energy is equals to m into g into h, 20 into 10 into 0, which is equals to 0 joules. So kinetic energy is equals to, okay, we know all the formula. So half into m into v square. So we know v is equals to what? All of you. V square. V square is equals to what, guys? Please respond. V square is equals to what, Hari? 2gh. So if we'll substitute it, half into m into v square means 2gh. So again, you will receives the formula, that is what? mgh. So at point E, kinetic energy is equals to mgh, which is equals to a potential energy at which point, guys? At point A. Means complete energy will be converting into kinetic energy. So I will say potential kinetic energy is equals to 800 minus 0, which is equals to how much, guys? 800 joules. That is what you have to remember. So total energy is equals to 0 plus 800, which is equals to 800 joules. So at every point, total energy remains constant or not? Verify it, everybody. At every point, total energy remains constant or not? Mr. Akilan, Kaushik, that is what you have to remember it. Do it now, all of you. Solve. You must solve, guys. Is actually completed?
Yes, sir.
Aswin Balaji, Sanjay Ganan. At every point, you have to prove that the total energy remains constant. So that is the question. It is. So all of you need to solve very clearly. If anybody is having anything doubt, please let me know. Okay. So at point A, only potential energy. And at point E, just above the ground, only kinetic energy. So entire potential energy will be converting into kinetic energy at point A to E, just above from the ground. Point E means just above from the ground. So that is how neatly you have to solve at every point who is remains constant. Mechanical energies remains constant. That is what you have to do it. So everybody must solve. So now here you put a statement. Always remember the potential energy lost by the body is equals to, understanding, loss in potential energy is equals to, what is that, guys? Gain in kinetic energy. So that is what you have to remember. So whatever the energy the body lost in the form of potential, that energy will be gained or transformed into kinetic energy. Hope you all understood. Anybody is having anything doubt, ask me. Akilan, clear Akilan? Abhirami? That is. So be very thorough. So always energies remains constant at any point. Maybe it can be transferred, so that from this example we can say energy can neither be created nor be destroyed, but it can be transformed from one form to another. So that is what you have to remember. So at every point, a freely falling body, at every point, some amount of, if it is falling freely, so at every point, some amount of potential energy is converting into kinetic energy. So when it is freely falling, understanding? So at every point, some potential energy converting into kinetic, and finally, when it is touching to the ground, so entire potential energy is zero. Only the body will possess kinetic energy. That is what you have to remember. At this point, only potential energy. At this point, only kinetic energy. That is what will be happening. So is there any doubt? Anyone? You can ask. Clear, guys? Yes, please. Now, the most important one. Observe very carefully. Now, I want the answer from you. Let me take the body is here and the total height from the ground, okay, from the ground is equals to 5 meters. What is the total height? Is equals to how much? Everybody? Total height is equals to 5 meters. Now, body will come exactly to the halfway, means h by 2. So, what is the potential energy and kinetic energy? I want the response from you all. Everybody? Yes, please. Check it here. When the body is at, 400 second, 4 meters, only total energy is 800 joules, only potential energy. When the body will come to point C, 2 meters above from the ground. So have you noticed it? Potential energy and kinetic energy both are what? Check it, everyone here. How much value? All of you. Yes, please.
Equal.
Equal. That is what I'm asking you question. So when height of the body become exactly half, then the kinetic energy and potential energy is also what? They will be equal. That is what. So that is why if you do the sum, the total energy remains constant. So from that, please all of you write the statement. This is the next discussion final point. At a height of at a height of h by 2, kinetic energy and potential energy, and potential energy are equal, and both equal to half of the total energy. Total energy. Is it okay, guys? What is the total energy name called as? Total energy name. Mechanical energy. Anytime doubt, anyone, you can ask. Clear? Till here, in no doubt, then we'll proceed further. So this is what the verification of law of conservation of energy, and the question which is given in activity 11.15. Hope you all understood. I don't think so you are having anything doubt. If anyone is having anything doubt, you can ask. Clear, everybody?
Yes, sir.
Yeah. Can make it. Now, if you understood this really, then we will go to the first one. That is what the next last concept of this one. That is what we will say rate of doing work. So that rate of doing work only we is to call what we is to call power. Okay. So please all of you keep reading. Right. Rate of doing work. So rate of doing work only what we is to call? All of you? Who is to say power? Rate of doing work called as power, right? Anyone having doubt? You can ask. Shall we start now? So now, you all know recently Mr. Arun also experienced this word called as capacity. What do you mean by capacity? You might be all knows that. What do you mean by capacity in general language? Please, mathematics it might become. All of you? What do you mean by capacity? Suppose I will say my water tank capacity is 1,000 liters. My water tank capacity is 2,000 liters. What do you mean by capacity? Capacity means what, guys? It is actually no. It is what? Volume of the tank.
Volume.
No. So capacity of a tank means volume of the tank. Now let us consider the situation to understand this rate of doing work, which we used to call as power. So I will take, suppose, consider an empty water tank of 500 liters capacity. So I'm having a water tank in my home. So which is having a water capacity is how much, guys? What is the capacity? Everybody? 500 liters. Understanding? Now, let me take which is present on the roof of a second floor and it is to be filled with the water. Do you understand, everybody? So it is in which floor? In my house? Second floor. Clear, everybody? So now, second floor means one more ground floor will come, correct? Sorry. So now it is above the second floor and it is filled with the water. Now, a strong man may fill this tank in 3 hours with the help of a bucket from the ground floor to the roof of the second floor. So I will put a competition to Mr. Omar, and let me consider he is a very strong man. So he has to take from the water from ground floor to the second floor terrace with the help of a bucket. He has to fill this tank. So what is the tank capacity? Everybody?
500 liters.
500 liters. So Mr. Omar has taken how much time, guys? 3 hours time. Okay. Now the same tank, just I will on the electric motor. If I on the electric motor, you all know in your home, everybody is having. If I have taken electric motor, the same tank can fill hardly how many minutes? Yes, please. Please respond. Same tank can fill hardly how many minutes? Hardly 20 minutes. Is it enough? Abhirami, in our home, you people might be having correct. So same can fill the same tank hardly 20 minutes. Is it okay, Hari?
Yes, sir.
It is not even required. Even within 10-15 minutes, it will be over. So now if you have noticed it here, the amount of work is same for both the man and as well as the electric motor. Yes or no? Everybody? Have you noticed it? Homer has taken 3 hours to fill the tank, the water which is present from the ground floor and the water tank is in second floor. With the help of bucket, he is taking and climbing, taking and climbing, taking and climbing. Within 3 hours of time, Mr. Homer has filled this tank. But if I on the electric motor, the motor can fill the tank within 20 minutes. Now tell me, work done by Homer and as well as electric motor, both are same or different. How many of you will agree or how many of you will disagree? Yes, please. Harish, Ashwin Balaji. Yes, please. Nobody?
Yes, sir.
Yes. So if you notice it, work is the same for both the man and the electric motor, but the time taken by the Homer is 3 hours as he is a person, and the time taken by the electric motor is just 20 minutes. So, for example, like our real life case will take one numerical sum I have given. Some people will solve very fastly, like 10 minutes or 20 minutes. Some people, even one day we can give also, they will still keep on thinking only. So, mean that both the work done by them, just casually I am asking, is the work done by them is same or not? They have taken one day and this person is taken 10 minutes. Still, the both are done the same work done, but only one difference you are noticing. You can see that Homer case and electric motor case. What is the only difference you are noticing? Everybody? Yes, please. Both work done. The work done by the Homer is equals to work done by the electric motor. So, but what is the difference? Please respond, all of you. Work done by Homer, which equals to work done by electric motor. So only difference is what? All of you? You can see that and you can notice it. What is the difference? Homer has taken 3 hours and motor has taken just 20 minutes. So that is what it is. So motor takes lesser time as compared to the strong man. So a time in which a given work is finished also matters. How fast you are doing or how slow you are doing. How much time you are taking to complete the given work. Either you are taking more work, more time or less time. So we can say that we should know how much work is done per unit time. That is what it will matters. So that is why we will introduce the new physical quantity which will tell us about how fast or how slow work is done by a body. That is what we used to call as power. So till now we are saying work done or not, but now we are saying how fast the work is done or how slow the work is done. That is what you have to do it. So that is why a physical quantity which will tell us how fast the work is completed or how slow the work is completed, that is only called as rate of doing work or speed of doing work, which we used to say. What is that physical quantity? Everybody, Gokul? Power. So if you'll observe this power, the power gives us the power gives the speed of doing work. Is it okay, everyone? Please respond, Mr. Noor, Akilan. So we will say power is defined as the definition already there, heading itself definition you have. So what is power? Anybody? Power means what? Power is defined as the rate of doing work. Rate of doing work. So now, let us take formula. So power P is equals to, all of you remember, power P is equals to work done by time taken. That is what you have to remember. That is the formula for power. So power P is equals to work done by time. Anything doubt? Anything ask me? Abhirami, Mitakshri, Harish. That is what you have to remember. So observe very carefully. Now same second floor, I will put two 500 liters water tanks. Okay, two 500 liters water tank. Now for this one, motor one is connected. Motor one. This is motor one, and this is motor two. So motor two. Now motor one will take 20 minutes. Motor two will take 10 minutes time to fill the tank. Okay. Now tell me, who is having more power, motor 2 or motor 1? Both are motors only. Now at least. Who is having more power, motor 1 or motor 2? Everybody? Work done by both motors is same. Work done is same. So who is more power? All of you should tell me. Work done is same, but both the motors. So who is having more power? Please respond.
Second motor.
Second motor, sir.
Because same work it has been completed in how much time? 10 minutes, but this motor has been taken 20 minutes. So I can say power is directly conclusions from this. Conclusions, observe. So conclusions, power is directly proportional to work done. So if I'm doing more work done, I can say I'm having more power. If I'm doing less work done, I'm having less power. And power is inversely proportional to what, guys? Inversely proportional to what? Time period. So if the body is taking more time to try, more time to finish the work, the body is possessing less power. If the body is taking less time to complete the work, then it is understanding. So what is happening? The body is having extremely high power. So that is the two conditions or two conclusions which we made from the power formula. Anything doubt? Let me know. Clear? Gokul, Aswardhan, Harish, Aswin. Anything doubt you can ask me. So what is the power formula, everybody? Power P is equals to what? Work done by?
Time taken.
Work done by time.
Time taken.
The body is taking more time, less power. Less time, more power. That is what you have to remember. Okay, Omar? Yes, please.
Yes, sir.
Now, let me take in this situation like Mr. Omar and motor is filling the water tank. That is what just in the second floor. Okay. Now we can say that a power of electric motor is greater than the power of a strong man Omar. So similarly, we can say a strong man is more powerful than a old man. Is it right or wrong? For example, same competition, I will keep instead of motor, I will keep to Mr. Omar and Mr. Aswardham. So Mr. Aswardham will do very fast as it is. He is a little bit fit more than Omar. So Mr. Aswardhan can fill the tank more faster than Omar. Yes or no? Because he can work. Omar is having little laziness. So Omar better than more than Omar. Aswardhan can do very fast. So who is more strong? Who is more powerful? Aswardhan or Omar? Yes, please.
Ashwin.
Aswardhan. So same way if you have taken young man and old man. So both may can do the work, same work, and they can work done by them is same. But who can do faster? Old man or new man? Yes, please. New man. New man means that is what young man we can say. Okay. Now, if you have taken your suppose now somebody is riding the bicycle and someone is going by car. So they suppose they both travel 10-kilometer distance. Now work done by them is same, but who has been more powerful, car or bicycle? Everybody. Yes, please. Car or bicycle?
Car, sir.
Car, sir. So that is what you have to remember. So at every time the who is doing more faster, how fast the work is happening is decides the power of the body. That is what you have to remember. Is it okay, everybody? Clear? Please remember. Yes or no, Harish? Okay. Now, let us take one more situation. We all knows, we are all very familiar with this. It's not a new thing, but it will be little different. Now, for example, let us take only Omar case alone. Observe very carefully. Now, Omar is present at which floor? Tank is present at which floor, guys? All of you. Ground floor, first floor, second floor. So let me take, here is the tank. Tank is present here. So this is the water tank. So now Omar has to fill this water tank with the help of a staircase or whatever it is. Okay, Omar? Ready, Omar? Now, so Omar,
Yes, sir.
ground floor water tank is here. So he has to take the water from the bucket, with the help of bucket, and he has to fill this water. So what is the total time taken by the Omar, everybody, to fill this water? Total time. Total time is equals how many hours he has taken? We have assumed that to fill this tank, how many hours? 500 liters. Okay. So how many hours it has taken? 3 hours.
3.
Now, if you'll observe, let me take the size of the bucket which is Mr. Omar has taken. The capacity of the bucket is 10 liters. How many liters? Capacity of the bucket is how many liters? Volume of the bucket. Capacity of the bucket is how much? 10 liters. Now, you can see the beginning, Omar is having more energy so that he will carry the bucket very faster. So within 1 hour, he can fill almost half of the tank within 1 hour. Means very fastly, because as it is initially we are having more energy, more fastly he will carry from ground floor to the second floor, ground floor to second floor, ground floor to second floor. Now when the time keep on increases, do you observe that the speed of Omar will continuously is remain same or keep on decreases? That is what my question. Anybody? Yes, please. Is Omar will carry the water as same speed as at the beginning, or slowly the speed of Omar will decreases when the time goes on increases? Everybody?
Decreases, sir.
Decreases because the man will feel exhausted. Mr. Omar will feel exhausted, so that you can see the speed of his doing work slowly keep on decreases. Means, have you noticed it? Initially, he is taking the water very faster and filling the water tank. When the time goes on, the speed, the speed of water carried by Oma is slowly decreasing. But still, is the power of the Oma changes? Power is only considered for what time? Total time taken by the person to complete the work. So maybe first half an hour he can do more faster. Next half an hour very slow. Last half an hour extremely slow. But still, what is the total time taken by him? Everybody? Yes, please. All of you. Please respond. Only total time taken by him is how much? Mithashri? 3 hours.
3 hours.
So you have to remember, maybe a person at beginning, he may be very actively participating. When the time goes on, due to the loss in energy, feel exhausted, but still the power of the man will be counted only when he fills the tank completely. Understanding, Harish? So to make you this point very clearly only, I am saying you this. Only will consider power when the tank is completely filled. Understand, Sanjay, Aswin, Noor? We won't consider middle, how fast or how slow is doing. For me, it's not a matter. For me, only what matters? Only total time taken by the total time taken by the person to complete the work. So middle he can do very fast or very slow, that is his problem. So only we will consider the power of a man will be counted when he fills the tank completely. So that is why we can say a power of a man at the end is average power. So sometime his power is beginning more energy, more faster, last exhausted, very less. So that is why like average speed we people will take same way. We will take average power of a body. So average power, can you tell me the formula everybody? Average power is equals to what will come guys? Everyone. Again same thing. What is that? Total work done divided by what, Hari?
Total time taken.
Time taken. Like same thing, distance, we will find average speed and average velocity. Do you remember? Yes, please.
Yes, sir.
Same way here we are solving. Nothing we are doing. Abhirami, understand Abhirami? Akilan, Gokul, anything doubt?
Yes,
Please.
sir.
That is what you have to remember. So, whatever it is, people can do fast or slow, their choice. But I want to only consider total time taken by the bodies. That is what you have to remember. So, you can see since work done is depends on energy supplied, all of you should remember an equivalent amount of energy has to be supplied to carry out the given amount of work. So we all knows energy possessed by the body, which is equals to what? All of you? Energy possessed by the body, what? Which is equals to what? Energy possessed by the body is equals to work done. That is what it is. So, energy supplied by the body is equals to work done. That is what you have to remember it. All of you make it. Clear? Harish? Yes, please. Can you hear me? Akilan? Noor, can you hear me, Noor?